Okay, so let's talk about this is, I believe, Thursday's warm up, if I'm not mistaken. Um, as of when you got this warm up, this was like less than 24 hours after you learned what U substitution was. So probably if I gave you this same problem today, you would do a lot better, or at least I hope you would. And some of you may be able to look at your work and already know what you did wrong because we've been doing this for now. This is what our third full day of U subbing. Anyway, so first I like to start off with what I consider the exemplary answer. This is a very good work. Um, you have our U right here. The DU is clearly defined. I loved that this person put the DX as well. That is what I like. That is what I like to see. A lot of people leave the DX off, and honestly, you could get away with that. It's not a big deal, but I think it's bad practice. I think it's better to have it in there. You see the 3, the 1/3, the converted substitution right here. I believe if you got the substitution done correctly, I gave you at least a 3. Anything beyond that would be how well you found the antiderivative. Um, to do this antiderivative, you do need to bring the u up. And again, notice I gave it away. I've eliminated 4 people. So this person brought the u up, kept the squiggle s in the du because bringing that u up is not an antiderivative move. It's algebra. So you keep squiggle s in dx or du, and you lose it when you actually add and divide. The only thing that I would like y'all to do that this person did not do, and it's fine. It's nothing wrong at all with this answer. But while there is no risk, there's no points going to be deducted if you mess up. I would like for you to go ahead and practice doing a full simplified answer, which would move that x squared plus 3 back to the bottom. And 3 times -3 is -9. I actually stuck the negative in the numerator. So I would like for you just to go that one extra little step and simplify your answers just for practice, because if it's multiple choice, they almost certainly will do that. So while there's no risk in points being deducted, go ahead and take that chance. Son of a! Is it really?
Yes.
Fine. All right, x cubed. I think I was looking at that thinking that was a 2, but that is a 3. Now that I look on my monitor. And also, another reason why I chose this person, there were several people who had near perfect answers. One of the reasons I chose this one is because this person circled yes, but with the notes if I get it right. So if you want to do that, that's fine. I will, if you do that, I will assume that if it's not perfect, that you don't want me to show it. So if you want to put like a condition to your volunteering, you may do so. Yeah. All right. This one, let's talk about some common mistakes. And this is not exactly the mistake that I wanted to show, but it was kind of in the ballpark. And this is, again, because y'all were new to substitution. But a lot of people, and it's hard to tell, but the substitution, I believe, is correct. This should be a u, not an x, but it's 1 over u to the 4th. We do have the 1/3. But then you'll notice that this person never actually found the antiderivative. They did the initial substitution, but then just plugged the u right back in before actually finding the antiderivative. And I've seen that mistake in all 3 AP classes. As we've gone back from break, we're a little bit rusty. Just remember, you need to actually find the antiderivative before you substitute or do anything like that. Good? Good. This one is the most common. This is probably the most common mistake when it comes to antiderivatives. Substitution is perfect. There's a missing dx here, but that's really not that big of a deal because this stuff right here, there's a lot of chatter. Can we stop with the chatter, please? This stuff right here is kind of like the number line. Remember, the number line doesn't count as work shown. There's not really a standardized way for number lining. That's the same thing when you like make notes to yourself on what u and du is. So if you don't write the dx, it doesn't hurt you. But I think it's kind of a bad practice. What are you doing, Harris? That is distracting me, and I can't even see what's on it.
Sorry. I was trying to do something.
He's like waving his Chromebook around like a flag. Anyway, so back to this one. Substitution is perfect. 1 over u to the 4th. Very, very, very common mistake is people see 1 over stuff and it reminds them of natural log because the derivative of ln x is 1 over x. And so a lot of people do this. I think people did it in both classes, and I see it in BC a lot as well. But remember that an antiderivative will only be a natural log if the top is the exact derivative of the bottom. The derivative of u to the fourth would be 4u cubed, and my top is not a 4u cubed, it's just a 1. So go ahead and think natural log because it's a quick thought, but just verify that the top is derivative of the bottom. If it's not, then we have to bring that bottom up like we did, like I showed you earlier. Good, bad, ugly? All right, onward we go. I believe these are from third period. This is what I'll consider an exemplary answer for Fridays. And the reason I like this one, by the way, a lot of people got 5 out of 5 on this one. So this is a really good one. I like this one in particular because the work was shown very well. We have a very clearly defined u. We have the du clearly defined. The substitution is perfect. And then right here, you can also see where the limits of integration were converted. So I liked this one, but that is the key. You do need to remember that if you change your variables, everything changes to u's, including the limits of integration. And you had that option in today's warm-up. Let's see. Let's look at this one. Again, this one was almost perfect, and it would have been perfect if the person just quit writing. If none of that was there, this would be perfect. But this person, I guess, just thought, well, while I have some time, I'll go ahead and practice my integration skills. And so this person actually decided, I'm going to go ahead and find the antiderivative anyway, even though I already have the answer. And remember that if it's 1 over stuff, consider natural log. Top is not the derivative of the bottom, so this person should have brought the u up. It looks like she just did kind of like a power rule thing in the denominator. Not sure. So I just want to point that out. If this were a free response problem, that might actually work against you. Onward. And then the last one, this person just forgot to convert the limits of integration. I just wanted to stress that you do need to convert those as well. As a matter of fact, on these, if it's a multiple choice question, the very first thing I would do is convert the limits of integration. I've been harping on finding the du and all that mess, but because of the structure of this problem, I would convert the limits first because that is very easy to do. 0 squared plus 5 and 2 squared plus 5 will tell you immediately you're looking for an integral that is from 5 to 9, and you would have eliminated d and e right off the bat. So it's such an easy thing to do. I would go ahead and convert those limits of integration first, then work with whatever you need to narrow it down to the right answer. Are we good? Okay, how do we feel about the circuit? Okay, the answers are up. They have been all day. Are there any problems in particular that you would like to talk about? I ordered the bright orange paper because anytime I copy just like straight notes for you, I wanted it on something bright that you could find easily. I didn't realize I was ordering cardstock. So it's cardstock because I didn't know I was ordering cardstock, but I was more focused on the color. A? I can do A. A has been requested. So let me find A. Where's the circuit? Where's the circuit? There we go. Okay. I don't know if anybody in this class did this. So block A. Okay, calm down. We're excited. We are excited today. Okay. The important part of these circuits and stuff is just get practice doing these things. If I had a few people in third period who just like mowed straight through and just completely disregarded following the circuit, and that's fine. You kind of lose the aspect of being able to kind of check your work. But as long as you're working them, that's fine. A was requested in both classes now. It was the very first one asked. And my guess is, and I don't know, I'm not sure why. I know in third period, the person who asked for A thought every single problem had to be U sub. And they were like, where is the U? You don't have to do U substitution. I know. It does say that. That would be, that's I think this is Verge Cornelius, isn't it? Is her name at the bottom? Oh, there's no name on this one? Oh, okay. I stole this circuit from somebody else. Anyway, so don't start with the more advanced techniques. As a matter of fact, I'm going to go ahead and give you a list of all the integration techniques we're going to learn. We're almost done, by the way. Oh no! What? With integration techniques. There are 2 more, but the 2 that are left are not quite as layered as U sub. U sub has a lot more different presentations. So, I don't know. All right, so far we know 3 techniques for finding antiderivative. I'm going to call the first 2 1A and 1B because you almost think of them simultaneously. That would be what we learned last semester. The power rule, which you use for polynomials, where you add to the previous exponent and divide by the new. That's what I consider the power rule of integration. You also have just straight up recognition. So that'll be things like your inverse trig derivatives and trig derivatives, and 1 over x is natural log x. There's just things that you recognize and you know the answer. If it's not one of those 2, I would always consider those 2 first. And remember, power rule sometimes doesn't look like power rule right off the bat. Sometimes you have to do some expanding or STDs or something like that. If it's not one of those 2, then we try the more complicated techniques, starting with U sub. And the object of U sub, what you're hoping is that after the substitution, you get a new antiderivative that is either power rule or recognition. So you're going to hit reset, and it should give you one of those 2. You don't know anything after U sub, and I'm going to go ahead and give you the comprehensive list now. There is integration by parts, which is doing the product rule backwards. And parts is kind of like U sub in that it doesn't give you the answer, but it does change the problem into hopefully something you recognize or power rule. Every now and then it will give you a U sub. You go parts and then to U sub and then up to, you just kind of march up the line. And then the last one sounds very intimidating, but it's probably one of the easier ones of the more complicated techniques, and that is partial fraction decomposition. It's really not that bad. Yes, you did. You'll recognize it when you see it. And it'll bring back bad memories, but in the context of this class, it's not bad. All right, so all that said, always consider the techniques in that order. Do not start, when we learn how to do parts, don't start with parts. That should be like your second or third thought process. So start with power rule recognition, then try U sub. This is a polynomial. We're just going to power rule this guy. So it's negative 16, x to the 4th over 4 plus, I don't like that 7. I'm just going to ignore it. 2/5 plus 1 is 7/5. Divide by 7/5. That'll be times 5/7. And then the antiderivative of 3 is 3x plus a c. And then clean that up. These 7s cancel. 16 over 4 is negative 4. And I think the first several were just power rule, weren't they? Anybody catch that?
Yeah.
Or at least there were a few. Just 2. Okay. Any others you want to look at? Ready to move on? Okay. I want to, by the way, the answers are all here. So if you want to go in, and they're also linked separately in the calendar. So if you want the PDF of the answers rather than go through the notes, you can. I don't think we ever got to this particular problem on Friday. It's on that integration template sheet that has like 54 problems. By the way, I do have that worked out and I have the answers to that. I'll post that for you because we're not going to do all of them in class, but they do give you a good source of problems that you can practice with if you want something like that. There is one problem on the back in the exponential and log section where the antiderivative is just 7 to the x. And I don't think we talked about this one, did we? Yeah, I think I realized it was not going to be time to do it justice, so I stopped. What number is it?
30.
Okay, this is indeed a substitution problem. This is indeed a substitution problem, but it doesn't look like one. What do you think you would choose for U? Okay. Yeah. Except, no, that's okay if you think about it for a second, as long as you remember that, oh yeah, that's not going to help me. So we never do U equals X. We're going to have to choose something more ugly than that. Okay. The only other thing you could possibly choose is 7 to the X. But let's see where it goes. One of the good things about substitution is it's a very good technique that you can just kind of try stuff and see if it works. If it doesn't work, then you start over. So du, what is the derivative of 7 to the X? It is 7 to the x times the natural log of 7. And the dx is part of it.
Multiply both sides by that.
Yep.
By the dx. Is that what we're talking about? Yeah, because what you're really doing is you're doing the derivative of u with respect to x.
Right.
We're finding du dx, and I'm just multiplying by dx to move it over.
No, I'm saying like, so that you multiply both. Never mind.
No, she's saying you multiply by ln7 and the other thing.
Oh, yeah.
Yeah.
One-
Now we will do that. Now remember, the most important part of substitution is what?
Start with du.
Find the du. You must account for the du before you substitute anything else. I have 7 to the x and dx in the problem. I'm missing an ln7. Can we fix that?
Yes.
Yes, that's a number. It's a weird decimal, but natural log of 7 is a constant. So I can squeeze a natural log of 7 in here as long as I put 1 over natural log of 7 out here. When I do that, my du shows up. And as long as you see the du, you can go on with substitution. So let's do it. The 1 over ln7 outside stays there. I have the antiderivative. And I take the stuff that I boxed out and I replace it with a du.
There's one.
But I took everything away. There's not a u anymore.
Yeah.
So it's 1 over ln7 plus c, right? Would that have to be the answer?
Yes, close. Closer than what they were saying.
Yeah.
All right, it is a 1. As long as du is in the problem, you can keep going. It's okay if that takes away everything else. You don't have to substitute u in the problem, but you must get du in. What is the antiderivative of 1? No, I'm going to be picky. U. This is a du problem. If you write x, you're probably not going to remember to substitute it out. The antiderivative of 1 with respect to u is u. Right? Now that I found the antiderivative, a u does pop up. And now I can substitute 7 to the x in for that u. So the answer is 1 over natural log of 7 times 7 to the x plus c. Are we good? Weird, isn't it?
Where did that ln7 come from?
That's how you find the derivative of exponential functions. As a matter of fact, the formula is written on the side of the screen over there. The derivative of a to the x is a to the x ln a.
Yeah.
Is that the last problem we're doing with the textbook? Problems today?
Of that sheet, yes. Yeah. Anyway, are we okay with that? It's kind of weird. If you look at that orange sheet, if you look on the left side, it's on there somewhere. Where is it? Okay, first, I put it on bright paper, so it'll be easy to find. I'm blind. You'll see number 16. Number 16, that is essentially what we just proved. Okay. By the way, we do not need to memorize everything on this sheet. I know it looks intimidating. If you love to memorize and you soak stuff up like that, then sure, memorize it, whatever. You should already know 1 through 13. 1 through 13 are the derivatives we learned last semester in reverse. Okay. We'll talk about these down here. You don't need to know most of these because most of them you kind of figure out on your own anyway. We've been doing USub for several days and we haven't used any of these formulas yet because usually you can just kind of feel your way through the problem and you don't have to go through a memorized formula to produce the answer. There are a few of these that are worth memorizing. We'll talk about that a little bit later. Yes, sir.
Knowing the kind of person you are, you're going to give us a quiz on this, aren't you?
This?
Yes.
Oh, well.
No, I
don't know what
I'm just putting it out.
Are there teachers
No, do you
who
not realize he's already thought
choose what they're going to do based on what students say?
Yes.
Yes.
To make
That's a good idea.
No.
Yeah,
Don't
okay.
enjoy students or teachers.
Now, we do have, if you remember the scary post I posted last Wednesday, we do have a quiz this Friday on substitution.
Is it gonna be?
You'll be fine.
Okay.
It's fine.
Is it like
Um,
Yes.
No, it's going to be problems kind of like that. We'll talk about it later. We don't need to stress about that right now. No, not multiple choice. All right. We'll come back to that orange sheet in a second. Let's see. I want to look at these 5 problems. We're going to work them together kind of like notes. There was a video that we watched a couple of days ago that we were supposed to watch for homework, but then we never did come back and work problems like what was on the video. So, that one, the one that had double substitution and stuff like that. I want to look at these problems. I think. So I'm going to reorder them. I'm going to do them. Move 52. We'll do them in this order: 28, 38, 52, 49, 48. That is, I believe, in maybe increasing difficulty. I don't know what's harder. 20. What do you think looks worse, 28 or 38? Okay, we'll do 28 first then. We're just going to work these together as notes. Is that okay? And tonight's homework will be to watch a video on the stuff that's on that pink sheet.
But it was 28, 38, 48.
Right there. And if you like the touch, feel, and taste of a textbook, this is page 467. You can pull your textbook out and look at it. All right, so let's talk 28. What are you thinking? Okay. And always try to anticipate what I'm going to do. I could get a sixth grader in here who can look at the screen and write down what I write. That doesn't take much brain power. Try to think about what I'm doing and try to anticipate what I'm doing. Don't just copy down.
I said you just called me.
Okay. If u is x plus 2. Yes, sir, ma'am.
Could you just bring the x inside?
Can-
Like x partially 2x squared, and then just solve it normally.
Okay. So, no, you can't. Okay, we're goofy today. Let's calm down a little. Okay, so always think algebra. There are a lot of problems that you might be able to do u substitution, but you could also very easily expand into a power rule or something like that. So it's something I want you to think about, and that's what Lily is doing. And she's thinking, is there a way that I can, and if I'm understanding you correctly, is there a way I can take this x and kind of squeeze it into these square roots? Technically, there is a way to do that. However, it doesn't help. And I don't think I've ever done that where it made the problem easier. I think it's always going to make it complicated. I feel better, even though I just kind of told you it is possible. But the reason I don't want you to do that is because distributing is an act of multiplication, right? In the order of operations, we have to take care of exponents before you multiply. So you have to do something with that 1/2 before you're allowed to take that x into the problem. It's kind of like if it were x times x minus x plus 2 to the 5th, you probably wouldn't think to distribute the x because the 5 is a more obvious exponent that you would need to expand. Kind of the same thing here. So no, we're not going to distribute the x or bring it inside the integral. It is substitution, and u is indeed x plus 2, which means du is 1 dx. Is that in the problem?
Yes.
Yep. And as long as du shows up, that means we can keep going. So, come on. So du. Now I start taking everything else out. I have an x and a square root of x plus 2. One of those is going to be easy. Yeah. X plus 2 comes out and is replaced by a u. But, and this is what was in that video that we haven't talked about since, there is still an x remaining and you must account for that.
You have to add 2, or it's u minus 2. Right?
Mm-hmm. It's u minus 2. Right? And what you need to remember is the act of substituting. Now, I know we did a derivative. We differentiated the u to get our du. But the actual substitution step is algebra. There are two things that are equal to each other that allow you to move them in and out or swap them in and out. As long as we're in the world of algebra, we can do anything we want to with any equation we have. Like this doesn't help me at all, but I could, if I wanted to, I could square both of these. And u squared would be x plus 2 squared. Now that doesn't help me one bit in this problem, but that's an algebra maneuver, and whatever you do to one side, you have to do to the other. What I will do that comes in handy is I can subtract 2 from both sides, which will give me x equals u minus 2. which then I can take this x out and replace it with a u minus 2. We okay? And then, remember the object of substitution. The object of substitution, going back to that list that I gave you a second ago, somewhere there, is to bring it up to either power rule or recognition. Did we do that? Well, it's currently a product. It's u minus 2 times root u. So it's not a power rule or recognition yet. Can we make it one? How? Now I can multiply it. Because when we did that substitution, the weird exponent is no longer on the x plus 2. It's no longer on the binomial. It's on just the u. Now I can distribute through these parentheses because there is no longer an exponent on the parentheses. And when you distribute, just remember you add the exponents. So u to the first times u to the 1/2, that's u to the 3/2, minus 2u to the 1/2. Yeah. Can you finish it from there? I'm going to give you a minute to finish it. That's a game, isn't it? Calm down. It's fractiony, but it is a power rule. Just be careful with it. And if you want to cancel these 2's, that's about the only thing you can do to simplify it. There's really not much else. And I decided as I did the power rule, 3/2 plus 1 is 5/2.
That's 2 over 3. Yeah, it's 2 over 3.
Yeah.
Yeah,
Yeah, no, I that so nothing does. So I guess all you could do is multiply the 2's then, because we have this 2 from the coefficient, and then this would be 2/3. So you can make that 4/3, and that's the only amount of simplifying you can do. Good.
I'm drinking. Oh my goodness, people. Oh, one person.
Okay, let's look at 38, and try not to get scared. I don't know. Sure. I kind of think this is mother-in-law territory. It's not as bad as it looks. Yeah. Not as bad as it looks. And I'm just gonna give y'all like a few seconds to think and anticipate what's a u. Okay. If you let u be x squared, what is the derivative of that? 2x dx. Do we have a 2x dx? No. Can we?
Not really.
Mm-mm. Because I need an x times the dx. I do have x's down here, but that's a divided by x. It's not a times an x. So this is why I keep saying u sub is a good one to try, because if you choose wrongly, you should find out very quickly that you're going down the wrong road. And that's what happened here. So x squared is worth a shot as long as you differentiate correctly and realize it doesn't work. So now we're starting over. Okay, I would try the pi over x.
I would give you element.
Ooh, be careful. Yeah, we need the derivative of pi over x, not the antiderivative. That is also a very, very common mistake, is people accidentally go in the wrong direction.
Why don't you move the x up?
Mm-hmm. To find the derivative,
Which is
we will make that pi x to the -1, and it's a power rule derivative. Negative pi x to the -2. Is that no problem? Yeah. Yeah, because that's the same thing as negative pi over x squared dx. I've got the over x squared and dx. All I'm missing is a negative pi, and that's a constant. That's a number. We can fix that. So we'll squeeze a negative pi in here somewhere. I'll offset it with a -1 over pi. And this one substitutes very nicely.
so. How many of these type problems were like? I feel like this is. It's not like super thinking outside the box, but it would be considered like
I don't know.
Challenging.
Maybe. I don't know. I got to make the quiz.
How many questions do you think the quiz would be, though?
How many what?
How many questions do you think the quiz would be?
I don't know.
He hasn't made the quiz.
I don't know, but you can.
6 maybe?
6?
7? Alright, so when we substitute, take the pi over x squared dx out, that is replaced with a du. And then we're left with cosine of pi over x, but pi over x is u. Cosine of u. Yeah. And that's really clean. What's the antiderivative of cosine?
Negative sign.
Which one? Positive sine. Sine of u, and I'm going to go ahead and put my u back in. Yeah. So it's kind of ugly, but it actually substitutes very nicely. Cool. Proceeding. Proceeding. 52. Slowly upping the difficulty. What would you choose for u? I like the x squared plus 1 because it's inside the radical and it's kind of ugly. What would du be? The derivative of x squared is 2x.
Unless you
Wait, you get out of the x to the power of 3. You take it out of the x to the power of 3, right? And then you minus 1.
Okay. This is a little bit hidden. We're going to look at a couple of problems today where the u or the du is kind of hidden. It's there. X cubed is the same thing as x squared times x, right? I'm going to take one of those x's out of the x cubed to pair with my dx to complete my du, right?
Like, how do you think about it?
So I'm gonna break it up, and I'm gonna break it up really big. I'm gonna put x squared here. You agree that x squared times x. Now that's a really big space for multiplication, but x squared times x. I still have x cubed there, right?
Yeah.
I'm gonna put the square root between them, and now I can put a 2 and a 1/2 up front. Are we good? Yeah. And that's one of those things, like, I mean, if I gave everybody in here 10 or 15 minutes, maybe a few of you would have stumbled on that. But a lot of times you just have to see it once just to know that it's an option. Once you see it done, now it like opens up this new door and okay, now I know I can look for this. But you kind of have to see it before you realize it's an option. Good. So now we start substituting. We have 1/2 on the outside. That is now a permanent fixture of the problem. The 2x dx way over there is my I am having a really hard time with the squiggle s. There we go. 2x dx is du. Square root of x squared plus 1 will become square root of u. Oh, yeah, we still have an x squared, right? That's actually going to be kind of nice because if u is x squared plus 1, then x squared is u minus 1. Subtract that 1 over. As long as you're doing algebra, you're within the substitution rules. So that x squared is coming out, and I'm replacing it with a u minus 1. Does that look at all familiar? Yeah. It's almost identical to the first problem. Now that we're at this point, from this point on, we would make it 1/2 antiderivative, and root u is u to the 1/2, so that would be u to the 3/2 minus u to the 1/2 du. And I'm actually going to stop here with this problem because it is a carbon copy almost of 2028. Is that the first one we did? Cool. Sneaky? All right. Let's keep going. I think I had time in third period to finish that one. And we may come back and finish it. I just want to make sure I get these last two out of the way before the bell rings. All right. Slowly upping the difficulty. What do you think about you? Actually, I shouldn't ask that question first. I should ask, is this recognition or is it power rule? Is it one of those two? No. It is. It doesn't look like something I have memorized, and because we're dividing, it's not a power rule. It'd be like a quotient thing. So now we're into U sub. What do you think? Okay, we generally pull from the denominator if there's nothing else that looks viable. What's the derivative of that? 2x dx. Do I have a 2x dx? Stupid. Almost. There's an x, right? The 2 is not a problem. We know how to fix that. But even if I multiply by 2, the problem is I'd have to multiply the entire numerator by 2, and that gives me a 2 plus 2x. And even then, it's not just an x times the dx. There's that 1 plus with it. So no, the du's not there. That's kind of frustrating, isn't it? I'm not going to erase that work, though. You know what I do want to erase? Let's just get rid of the 1. There we go. Now we can do it. Harris, is that cheating?
No.
You don't even know what I'm doing.
Of course not.
What are y'all doing over there?
A
Okay.
survey on autism awareness. You're welcome.
Why?
It's for good cause. Okay, I'm ready.
It wasn't for a good cause.
I check it out.
Okay.
We're doing our part.
Anyway, so I erased the 1. But no, you can't do that. Can't do that.
That's cheating? Okay.
That would be cheating. Although I am going to do something that effectively does the same thing. We can't just erase the 1 though, but I am going to change this up a little bit. What if I gave you, and I'm going to erase this, but what if I gave you this one? What if I said x plus 1 over, and it was just an x squared? What would you do with that? Okay, that's one option. We could bring the x squared up and distribute an x to the negative 2, which effectively is the same as an STD. You could STD that, right? You can make an x over x squared plus 1 over x squared, and we would have 2 things to work with, but they would both clean up and work nicely. 49 is an STD. What is STD? Do you even remember what that stands for? Single term denominator. Now, you may be looking at that thinking, wait, there's 2 things on there. There's a 1 and an x squared, and technically you're right. But as long as you keep the denominator intact and you treat it like just one big entity, then you can separate any addition or subtraction in the numerator. And I'm going to do that here. I'm going to turn this into 1 over 1 plus x squared. I'll find that antiderivative, which that one should be absurdly easy, plus the antiderivative of x over 1 plus x squared. And in doing that, it's almost like I erased the 1, which I jokingly did a minute ago, but now I use legit math to get that 1 out of the way.
Yeah, who made this up?
That's a good debate. Is math made up or is it discovered? I don't know. Okay. So now back over here, I can do my substitution now. I can put a 2 and a 1/2, except this is the one instance where I will not actually do the substitution. I'm not actually going to write a new integral in terms of u, because I am now looking at a fraction, and every time I have a fraction, yeah, if the top is the derivative of the bottom, and I want you to think of that first, because it is a fleeting thought. It takes about 3 seconds for you to look at a problem and see if the top is the derivative of the bottom. It is. And so the antiderivative of this right piece is 1/2 natural log of 1 plus x squared. Are we good? About a minute or 2 ago, I wrote 1 over 1 plus x squared, and I said that should be absurdly easy. Why? That's the derivative of arctan.
That's like a nightmare answer of an answer.
Good?
I want to imagine that aliens come to this planet
And give us
and
the
they
math.
land in this classroom and they see students supposed to learn this is stupid. And they don't know what calculus is. And somehow they travel into the
Aliens would know what calculus is.
No,
They would.
see, if it was
You think math just quits existing in our atmosphere?
maybe it has different
Math is made up for.
There are scientists that don't.
All right. This is a philosophical debate that we can have after school if you would like. So let's talk about it later. I don't want to waste school time discussing the importance of math in that context anyway. All right, 48. Another fun one. Going to open your mind a little bit more. For the sake of time, I'm going to assume that you would look at this and consider u as 1 plus x to the fourth. And this is a case where you can almost attempt the substitution in your head. I don't mean finish it. You wouldn't be able to do all of this in your head, but at least the thought process, what is the derivative of 1 plus x to the fourth? 4x cubed. And you can very quickly look at that and tell that we don't have an x cubed in the numerator. So I hope that if you thought 1 plus x to the fourth, you differentiated in your head quickly and dismissed it, because it doesn't work. And this is a case of a problem, and you cannot STD this, because STDing separates addition in the numerator. You cannot separate the denominator pieces, right?
Can you factor?
Okay, it does not factor. Okay, so what I'm going to do is I'm going to choose backwards. So far, every problem we've done, we picked u. Then we looked for the du. I'm going to go in reverse. I'm going to look at what's available for u and let that drive, available for du and let that drive my u. And I have an x to the first dx. That could be my du if I let u equal what? What kind of function gives me a derivative of x to the first?
X squared over 2.
X. Okay, I'm going to go simple and just say x squared. Is that okay?
Yeah, that sounds good.
Okay. Because if u is x squared, what would du be? It'd be 2x dx. I can fix the 2 though. X squared over 2 was fine, but it's easier to fix it this way. Are we good? So what I've done is I've let what's available for the derivative drive my choice for my u. Because the du is that important. The du is that important. Now, as I start to substitute, because I do have the du now, I have a 1 in the numerator, I have a du. My denominator is 1 plus x to the fourth. How would x to the fourth work?
X squared.
X squared.
It's x squared squared. Right? There's several ways you could think of that, but that turns into 1 plus u squared. Yeah? Y'all, I told y'all this is difficult stuff, and I've been out there watching y'all today, and a huge chunk of y'all are not really dedicating your brain to what we're doing in here. You're kind of halfway paying attention, you're checking your phones between problems, and every time you do that, you break your thought process, and your brain has to start over with the next step. It makes it very difficult to soak this in. So those of you who have been doing that, that's your choice. You're almost in college. I'm going to let you make that choice. You're young adults, you got to do that. But it's going to work against you at some point. This one does finish up to 1/2 arctan u. There we go. U is x squared plus c. There we go. And there's a video for you to watch tonight. It's already linked and ready to go. It's brand new. Maybe I should have changed shirts to record it so it looked like I did it earlier instead of haphazardly during fourth period. All right.